Welcome to this workshop of Research Methodology and Biostatistics conducted by MET Division of RML Hospital. Numbers in the audience speak for reputation enjoyed by Dr. Siddharth Ramji amongst medical fraternity, amongst faculty and residents. Research methodology is a very important subject, but its importance and popularity both have been realized by very few teachers, and Dr. Siddharth Ramji's name is on top of the list. Dr. Ramji has, he is the only Maulanian to have occupied the position of Dean Maulana Azad also. And the rare distinction, only distinction in the history of Maulana Azad, that he had two signboards outside his Dean's office. One showed Dr. Siddharth Ramji, Dean Maulana Azad, and one in the adjacent corridor showed Dr. Siddharth Ramji, topper, MAMC 1978 batch. He is my batchmate. मैं तब भी इनके सामने कुछ नहीं बोलता था, सीखता था जरूर. Sir ji, आइए शुरू करिए. Please welcome. I welcome Dr. Siddharth Ramji. Is there a hand now? So no? All right. So let me first ask how many of you are residents over here? Can you just put up your hands? Okay. And how many of you are out of these, how many of you are senior residents? So all of you are, majority are postgraduates, and there's some faculty. All right. So, yeah. Normally I like to do these sessions in a more compact where we can interact. So I'll try to make it. Unfortunately, I don't have a blackboard because that's my habit that we keep using, but I'll try to use this as much as possible to take you through two things we will do this afternoon. First is developing a research question and hypothesis. And then from this research question, how do you decide what kind of a study design should you be adopting, right? So that will be... so can somebody amongst you tell me what is a research question? To know something in depth, all right? Anybody else wants to try, ask what you understand by research? Somebody there? Gentleman in the pink shirt? Yeah. Will you give it a try? So research doesn't gather the evidence. Research gathers information from which you're going to deduct whether that is sufficient evidence or not. So evidence is an inference on the basis, reasonably good. So let me ask, since you said it's collecting information, we have the decadal census every 10 years. There are surveys. Do you call them research? I like to call that research.
No, that won't be a research.
Why?
You pointed out, it's just gathering data. And
no. Even for doing research that you all do as part of thesis or whatever, you will have to collect some data, isn't it?
Yes, sir.
But what is the difference between that? It's just kind of embedded in this, what you see there. So you have to ask a question, right? Collecting data is one thing, but if gathering data, please sit down. If gathering data is to answer a specific question, that transforms from just collecting data for the sake of collecting data and
and or answering the question, getting the evidence for that. So it's so there are many definitions for research. I'm not going to go into all this. But to me, is this bottom line. You're seeking something. You have something in the mind saying that, why does this happen? Okay? What did Newton do? Newton saw an apple fall. Well, somebody can just be very happy about it. So the apple falls, so what? It's been happening for years, decades, centuries. But the difference was he wanted to ask the question, why is this phenomena happening? So the moment you put a why in front of it, to a phenomena that's happening, and then you start doing some experiments, data, whatever, that becomes your research. So remember, it's essentially seeking, okay? Which implies that if you have to do any research work, that means you have to first pose some questions to yourself. You have to have some questions, right? So that is the beginning of this whole exercise. You need to have an idea that emerges from somewhere, right? So how many of you are pursuing a thesis work? Nobody? Nobody doing thesis? Huh? Okay, yet to start, doesn't matter. So which year are you in? Oh, you are just joined, 3 days old babies. Okay. All right, let me ask you, which department are you in? Very good. Excellent. So can you simply, you have been through MBBS, you must have seen many things, one as a student, one as a patient, maybe yourself, or maybe your relatives went somewhere. So tell me something which you think should be a question that you should simply ask, which you don't understand and you want to look for it. Doesn't matter if it's, don't worry about whether it's known or not. Look at yourself. Do you know something? So what do you think in radiology or radio diagnosis is a question that bothers you, for which you don't know an answer? Just it doesn't matter. I'm allowing all of you. You can open to anybody. Just give a thought to it. That's, you have to ask these questions. Otherwise, you can't do research. Okay, the problem with thesis is that your guide does the thinking, but I want you to do the thinking today. Sorry? Like what? Give me one clinical example. So let me pose a question to you. All right. You do an ultrasound. The ultrasound is all shades of white to black. It's a gray scale, right? How do I know that, let's say a mass, it has a certain shades of gray or black or whatever, to say whether what I see there is likely to be benign or malignant? That's one question that you can pose to yourself. It could be for radio ultrasound, it could be for an MRI, it could be for whatever else. So you need to have an idea. Then what do you do with that? Okay, can you tell me? We have an idea now, all right? What's the next step? What will you do? This is your question, mind you, right? This is what you don't know. So what will you do next? Come on. Your question has come up. What are you going to do next with it?
We will think of answers.
How do you get the answers? What do you do to get the answers? What do you normally do? Let's say you have a patient in the ward, you have a question. What do you do next?
We'll analyze the things.
No, you analyze. You have where are you going to get the information about how do you put the bits of the jigsaw puzzle together to get your final answer? What do you normally do? You can ask friends. No, you don't ask your friends. All right. Ask your seniors. Are you mortally afraid of them? You can ask your teachers. And of course, we have the wonderful Google Guru who can tell you. So you're looking for information which could have many sources. And the first thing you would look is there some published information on this? You go to a standard textbook first thing and see does a standard textbook have an answer to this? So sit down. So you have to first of all look at, you do some brainstorming with people. Do any of you know some answers to this? If people are able to tell you, look, I have all the answers that you need, then you say, okay, fine, good idea. I did not know, but I become more educated today, so it's not researchable. On the other hand, somebody may say, okay, we know something about it, we don't know something else. So then you say, okay, can I now start addressing that particular issue and saying what happens. So through brainstorming, you get to know how this idea that emerged, what is known about it, what is probably not known about it. And then, of course, this has to be backed up by adequate literature review, because every one of us sitting here may not know all the answers. So there's a big, huge amount of medical information that's growing every day, thousands and thousands every day. So you don't know in which part of the world some smart aleck like you also asked the question and took one step ahead and said, okay, let me do some experimentation, comes up with some answer. So you go through this process. It's an iterative process. Okay? You keep going round and round till you know that the question you asked, which could be modified, and say you started with this, either you dump it and say this is all known, or from that, through that literature review and brainstorming, some other idea emerges, and then you keep going round and round till you think, okay, here is an area that seems not to be adequately addressed. So you have to go through the process, and this iterative process between brainstorming and literature review identifies the question. All right. Now you have to ask, okay, I have a question, but what information do I collect? So your variables. Do I need the name of the individual? Do I need the age of the person? Has gender got to do something with it? Has something got the height and weight of the person? Has something got to do with the blood pressure, etc., etc., etc. So you are first going to ask this question as what all information do I need to gather which will help me answer this question, because that will have to be subjected to some kind of further analysis. So once you've got the question, you identify these variables, and then with that you formulate a research question. I'll come back to saying what components are, but then you've identified all this and you formulate a research question. For instance, let's say somebody says, I have this new drug in the market for the lowering of cholesterol, right? And they claim that it has less side effects, right? It is gender neutral. It works just as well as in males and females. That's the claim, and somebody has brought it out and you say, okay, well, let's put it to test. So which means that you're trying to look at the drug. So giving the drug or not giving the drug is one variable. That means what is the intervention somebody is getting. So your variable is whether the person is getting drug, no drug. What are you measuring? What's the output? So you need to have cholesterol. All right. Then the firm made a statement that it is gender neutral. So you say, okay, hold on. So I must have enough number of women and men, and you need to decide what age group they need to come. And you also therefore look at what are the other factors that affect cholesterol. It's something to do with your BMI, something to do with the diet, etc., etc. So you look at all those things which can affect cholesterol. Drug is not the only thing. Drug is here. Cholesterol is here. But many things happen in between which affect the cholesterol. So therefore you have to make sure that they are not having a role in lowering cholesterol, right? As somebody may be a great athlete, so he keeps her cholesterol levels good, doesn't touch doesn't go to McDonald's and wherever else and say, I don't, all this trans fats are terrible for me. So you have to look at all those issues. So you identify from literature what affects cholesterol, right? And then you list all those kind of things, the claims, and then you say, okay, I've got all the information. So when I'm going to do my study, I have to make sure that all this is collected. So that's the process that you kind of go, and you will then create a research question. Right. So what therefore should be the essential elements of any research question? Okay. Is there a clear rationale? Is there any basis? Biologic, epidemiologic, whatever. There has to be some basis to say this question has a rational. Somebody comes up and says that I believe that everybody who's got a dominant left lobe sees more green than reds. Right? So you'd ask the question, what's the rationale? What has the left dominant lobe got to do with color perception, etc., etc., etc.? So if you can establish that there is some such rationale, then you go ahead. If it sounds terribly absurd and it's a biologic impossibility, then you just dump it aside and say, I don't think this is a great question. So therefore, when you frame a research question, there has to be a rationale somewhere. The rationale can come from animal experiments, it can come from lab information, and so on and so forth, some epidemiological data, and then you say, this is what I wish to do. Have you identified in whom I'm supposed to do this? When I say population, it doesn't just mean human beings. It could be cells. It could be organs. It could be a digit. It could be one tooth. It could be a ear, left eye, right eye, So the question you have to be clear is, what is the sample that you have from which you're going to pick it up? So you have to identify, right? So in the example I gave you about cholesterol, so you have to identify which is the age group where this normally happens. So are you talking about somebody who's in their teens? Are you talking somebody in between 30 to 50? Are you talking about very elderly people? So you have to get clear where it happens. And then you have to know that we're talking about men, women. Does it exclude obese people, or doesn't matter who they are? As pregnancy not to be part of it, and so on and so forth. So you have to identify and say, what is my population in which this research question is being addressed to? So that is the next part of it, right? Do you have all the variables? We just talked about what the variables are. So have you got all the variables that you need? Have you sorted them out? Have you identified everything? Right? What are the problems we have in medical science, unlike social science? Is that we want everything to be empirically tested. You would apply a statistical test. Right? If you were to say, A says, I like B. How do you measure it? Yeah? Can you tell me? if somebody says I like somebody else or don't like somebody else, whichever way it is, how do you think you can measure that? How can you put it into a number? Is it possible to do that? Any guess? It doesn't matter. Sorry? No, tell me, for somebody, okay, you like somebody, how do you decide you like or dislike somebody? What is the yardstick you use in your own mind to say I like or dislike somebody? Look at yourself and say, okay, there are people I don't like and there are people I like. What measurements what did you use through your mind which filtered them and say, this person is likable, this person is not likable, this person is okay. Either way, it doesn't matter. Sometimes likable, sometimes not likable. Just be free to say how do you decide? Sorry, a little louder. Character. So how do you measure character? Huh? You can be a little louder. How do you measure somebody's character? That's the question. Remember, when you're a scientist, you're saying, I'm going to do research, so you have to be clear. You can't tell somebody, I'm going to measure character. How do you measure character? Because whatever you do, if 3 other people decide, I will also want to repeat your study, they must know what the criteria were. So what is your criteria of somebody's character?
Qualitative, no?
All right, doesn't matter, it's qualitative, fine. I'm going to come back to how you can assess even these so-called, that is the problem, as I said, in social science, which is not subjectable to a t-test or a chi-square, can't be done, but then there are other ways to do that. So you say, okay, I like somebody because he or she talks to me nicely, he or she is considerate to me, right? Or I like the person's color, I like the watch he or she wears, I like the necklace she wears, whatever. I mean, you have a range of reasons why you like somebody, all right? Not all of them are easy to put, but you can. Social science tries to do that. But then it's another way of doing it. The point I'm trying to drive home is, you have to be very clear that whatever variable you have, you must be clear how it's being measured. This is the fundamental. Sit down. How to measure something. And you can give your own definition. Nobody's going to challenge it. What I can say is, as long as I use your definition, this is the result. If tomorrow I change the definition, there's no guarantee that you'll get same result. So there's nothing wrong. You can always set up your own definitions and say, I look at this, and this is what I'm creating a definition for this, which is all right. We do that all the time in medicine. I'm a pediatrician, and we have these problems of how to diagnose pediatric tuberculosis, and we always fail. We always say, okay, we put all these criteria together. You never grow AFB, you never see AFB, right? So they have some definitions are used. Study A uses some set of criteria, study B uses something else. And one of the problems we end of the day have is, we still don't know, are we still talking about tuberculosis or not? The gold standard is not there, but it doesn't matter. So the point I'm trying to drive home is, you must be able to say that the variable that's selected is measurable. And that, it's easy. Weight, height is simple because you have a measurement scale and you have an instrument to do that. But there are things for which there are no instruments, like this. Liking somebody or disliking somebody. And that is a scale you have to develop. So you develop a scale and say, okay, this is the scale I'm going to use on the basis of which I'm going to do some analysis. So fine, just remember to do this exercise. And obviously it requires that it can be empirically tested to all the statistical tests you do, which is a different social science that uses a different method. They don't empirically test it, but you can come to certain conclusions based on some kind of clustering of information together, and you generate social science a lot of hypotheses, and those hypotheses can then be kind of tested through more empirical ways. So these 4 things, so whenever you write a research question, please make sure you have all this with you, that you are fulfilling these areas. Is this clear to all of you? Please feel free to stop me, clarify, ask questions. I should be more than happy to do that, right? So this is very important. It helps you. In all our research studies, this format is useful for you, which goes back to what I said. P reminds you that have you defined your population or subjects or whatever, right? If you're doing comparative studies, then you need a comparison, and one may be an intervention or a predictor. I'll come back to that later. And the other is a comparison group. But if you're just simply doing a survey, okay, if I was simply to do a survey and my aim was simply to know how many people in this audience have come because they're interested in learning about research, and how many have come because of danda from their guide, and so you better go and attend that class tomorrow, otherwise no thesis for you, right? So you have different categories of people, and I want to understand what happens. So I have no comparison. I just have all of you. I have certain characteristics about you, your age, whether you're first year, your second year, your subject, speciality, and then put some kind of a question and find out whether you're here because you like it or from other reasons. Right, so then I create a comparison within. I don't a priori define it, but you can create within that. And then my outcome is to know how many are really interested. So you have an outcome. All right, so remember you have a I and a C, which are actually what we call as the exposure. Remember, epidemiological science looks at associations. We're looking at associations. Is this associated with this? It doesn't mean cause-effect. It simply means cause-effect is also an association, but I'm just saying a general epidemiological principle is that you're looking at if you have more than one variable and you're trying to say, is this in some way associated with this, right? So the I and the C are what you call as the exposures. They're the exposures. The outcome is what we are looking at. So when I go back to the other example of cholesterol, the exposure is the drug, right? Drug or no drug, or an alternative drug maybe, okay? And the outcome is the reduction in cholesterol. That's your outcome. And we already have the population, right? It may also be nice to put in a time frame and say, okay, are we going to do this information in 1 year, 6 months, 2 years, 3 years? Because if you take conditions which are rare, let's say for HIV, it may not happen for 5 years, it may not happen for 6 years, it may not happen for 7 years. But we look at the risk of cancer. Here somebody is smoking, I wonder how long is it going to take the cancer. Depends on the age. Depends on his exposure, how many cigarettes he or she smokes in a day, what kind of cigarettes they smoke. So for somebody it may take 5 years, somebody it may take 10 years. So therefore, you have to ask this question, is it doable? Can I get the answer in the time frame that I have with me? And as postgraduates, our time frame is a year or 2. If you're an ardent researcher with numerous resources, let's say no limitation resource, and you've got 15 years, 20 years, let's say, okay, I can do this follow-up for 15 years, no problem, I'm still there. I will see what happens, select all the people, 20 to 25 years who are smokers, and say, I'm going to follow all of you the next 30 years and say how many of you end up getting cancer. So remember, the time frame is important. The limitation is only because of the research question and the time that you have with you and ability to do that. So this PICOT is something you must put into place. Right. So you'll see a little bias of my pediatric and neonatology. I can't help it, but I'll give you some examples all the same. So here's a research question, right, which says, would the topical application of sunflower oil reduce neonatal mortality in preterm infants? Right. So if you put it back into the Picot format, what is the P here? Sorry? Preterm. So you have to define what preterm is. Right. So one is preterm, but preterm is whole range, runs from 20 weeks to 36 weeks. So are we talking about 22-weeker, 23-weeker, 35-weeker? So you have to define what is the group you're interested in. So that's okay. I'm not saying you should get an answer. I'm just saying that it's not enough to say preterm. Preterm is a huge range. It's like just saying adults. Now, adults range from 18 years to 100 plus. Everyone's an adult. Okay? So you have to get focused and say, okay, what is the group you're interested in? So that's one. So because this, what's the exposure here? Sorry? Sunflower oil. All right, so sunflower oil is an exposure. Because you wish to compare and you want to know whether sunflower oil reduces, you can't get that answer unless you also have a comparison group where sunflower oil is not being used. Right? So the question could be that you use nothing, or somebody may frame and say, why only sunflower oil? I come from the heartland of UP where a lot of mustard is grown, so why not mustard oil? Fine, no problem. You can have a question which can be reframed to say, what the sunflower as compared to mustard oil, does it do the same? This is one way of looking at it. And somebody may say, forget all that, no mustard oil, I just simply want to know sunflower oil versus nothing. Does it make a difference? So that depends on your question. Okay, so the comparison is between the exposure here is an oil and maybe another oil, or it may be nothing. What's your outcome? Sorry? Neonatal mortality, which clearly implies that you must die within 28 days of your life. So that's kind of by itself. So you have the Picot broadly, so it tells you about the population. You can, as I said, you put it in place, but then you can, through discussions and literature review, refine it further to say what exactly is the population you want, right? Do you want babies who are not only preterm? Do you want somebody who's 500 grams? Or you want somebody who's 2 kilos? You know, you keep looking at all those issues. So the Picot then gets developed into, right. So this is what it looked like. So when you have a question, put this little framework and put this PICOT, say what happens. Okay. So here I modified this in a way to say that the maximum you need to follow up anybody is only 28 days. Each subject only 28 days. We're looking at death in 28 days. So therefore, the maximum any kid will have to be followed is not many years, just 28 days. So it's very simple. 1 month. The outcome is a mortality or a death. Okay? So you have all this which I just now said. Okay? We have the variables. So the variable exposure is, there are two kinds of variables we have. One is quantitative, where I can actually have a measure. Weight, height, numbers. Okay. The other is just a yes or no, male, female, black, white. They're all yes, no, deaths, alive. They're all just dichotomized. They cannot be further quantified into a mean, standard deviation, median, and so on. There's no numeric tendency to that, right? So here, the way you have a variable, the exposure, it's either using something or not using something. It's a yes or no situation. So this is qualitative. Remember all that, because tomorrow when Dr. Pandey talks about statistical analysis, you need to remember these little concepts because it's the kind of test you apply will vary. Right? Outcome is death or no death, which is also qualitative. There's no quantity here, right? At all. It just remains the way it is. So here you have an exposure which is qualitative, outcome which is also qualitative, so you need to remember that. And then when you have got all your data gathered, you know what kind of tests you have to do when you're comparing a qualitative with another quantitative. So we look at the association between qualitative and qualitative, or qualitative and quantitative, or quantitative and quantitative. These are the three possibilities you can have. can have either qualitative and quantitative, or quantitative and quantitative. Only three options. This is what happens in 95% of biomedical research is all these set of combinations. Okay, and that tomorrow you'll know. So just remember this. This is what you would eventually do. Let me take another example. So here your interest is to predict death and non-fatal myocardial infarction in high-risk patients, a comparison between a particular type of treadmill score, a peak exercise radiant angiography, and a SPECT perfusion image. Right? So let's translate this to my PICO. So what's my population? Sorry? So you have to define what high risk is. Right? You therefore have to know from literature or from standard information who are the people who are at risk of MI, who among them are more likely to die. Right? So there will be things like an age group, and you look at gender, and you look at their BMIs, and you look at their lifestyle, whether sedentary, non-sedentary, so on and so forth. You know all this that you already have, which is all standard risk factors now we know of. So that becomes your population. Okay, that is your P. All right. What's your outcome? What's the outcome? So you have two outcomes. One is death, and other is a non-fatal MI. Okay. And when I'm saying death, I'm not saying you're dying of MI. We're just saying death. Simply, what is the risk of you have a set of people, can I predict your likelihood of dying? Yes, the death most often may be due to MI, but it may also be to other reasons. You might have a stroke and still have a problem. You may have an intracranial bleed, something else may happen. But there are two different outcomes. What is your exposure? Do you have an exposure? You don't have an exposure because you're not saying something is leading to death here, but it is very similar. I'm trying to predict. So for me, I want to do a test to say that can I predict, are you likely to have these outcomes? So remember, when I say exposure always doesn't mean logical terms, something leading to something, but even ability to predict something or diagnose something can be treated as exposure for the purpose of understanding the PICO. So here we have three different exposures, if you like to call it, three different tests. You have a treadmill, so you'll have some value in the treadmill which will predict and say if you're above something, you're going to be at risk. If you're below this, no risk. I have an angiography where some findings of angiography I will define a priori that if you have this findings, you are likely to higher risk of death. And the third is on SPECT perfusion image. So you will get a set of values which will tell you either it may be numeric, it may be yes, no, I don't know what it is, but whatever it is, you may have a numeric value, in which case the exposure has a quantitative value to it, and the outcome anyway is yes or no, so it's only qualitative. But you may have some quantitative, the peak exercise scintigraphy may have a count. Your scintigraphy has a count. So therefore the counts become a quantitative variable. So you have here an example where you don't have classical exposure in the terms of a risk factor, but you're using a diagnostic test to follow. So what do you have to do? Pick them all up, subject everybody to this test. All have to do all because you're asking is one, in effect you're trying to say is A, B, C, they're all the same? Is one better than the other? Right? A treadmill is easier to do. A scintigraphy requires some more additional infrastructure. SPECT needs even more. So when you do research, you're asking questions about not only what is best, but you also want to give people choices. The health system may say, I want to do something at a CHC or a district hospital. Maybe what you can do is a treadmill. I don't think you can set up a SPECT or a scintigraphy there. So is there a method where I can screen out people doing something simple? And from that, can I send people to the next level? So these are issues that public health people keep asking. So this is what happens. So your PICOT will just simply, and obviously you'll follow these people up. So you take, let's say you have people between 20 and 25. Remember, today myocardial infarct is happening early. You get people at 25 and 30 who are getting MI, so it's no more. So you can't say I'm going to select people who are 30 to 40. Maybe 10-15% have already had the MI. All these guys with risk factors might have already had the MI. Maybe even died. So you have to look at what does literature say, what is the usual age when these events happen, and you have to make sure that these tests are being done sufficiently ahead of time. Let's say you take people at 20 to 25 and then say, I'm going to follow them for the next 10, 15, 20 years and see how many of them die or how many of them will develop. Then I will be able to, and all of them would have been subject to this test, and then I will look at those who die and those who don't die and look at what were their values. Is there something that makes them different? Those who had MI and no MI, were any of these different? So you may conclude to say that none of them predict, or some predict, or they predict not in all, but they predict in some people. Let's say better prediction in individuals who are obese rather than those who are not obese, more likely to predict in women than in men. Many conclusions can happen as a consequence of this. But that was your research question, but then within the subgroups you may find patterns. Therefore, either you may be able to answer that question, but very often what happens is that when you look at these little small subgroups, there is never enough sample of all of them, but it gives you an idea. So what invariably happens in some of them is a new idea emerges, a new hypothesis gets generated, and then you can do another study to see whether this kind of works. Your primary question, of course, remains like none work, but then you find subgroup patterns, and you may decide to, on the basis of this study, another friend of yours may decide to do another study. Sure, please. Yeah, fine, doesn't matter. Sure.
Hello. Yeah. So this is predicting mortality. So in a way, it is a performance of these three tests and a comparison, relative comparison.
Performance. Remember.
No. Not performance in terms of comparing the prediction.
Right.
So in a way, it is performance of this versus this for predicting.
Okay.
Now, I'm asking that normally when we do a diagnostic test performance, we would want a gold standard to compare against. So here in such a question, do we really, I know it's not relevant right now, I'm just asking of the...
So let me make a distinction.
Yeah.
This is not a diagnostic test. It is neither diagnosing MI nor is it diagnosing death. It's only predicting.
The predicting
So
is not...
predictors are a little different in the sense that it only tells you what a likelihood
Yeah.
of an event happening.
Yeah.
So, but diagnostic tests are different.
No, I'm not saying diagnostic, performance, that's why I said...
No, there are very many ways of looking at performance. For maybe tomorrow, I don't know whether Dr. Pandey will, but let's say you want to look at the performance of 3 autoanalyzers for measuring blood glucose. Right. So what do? You take the sample and you run the same sample on all the 3 machines, and let's say you do 100 people. And you have multiple values ranging from, let's say, a range of 40 to maybe 150. And then you draw an ROC curve, and then on the basis of that, you count.
Okay.
So that is, so we never use the term, when you say performance, then it is looking at measurement of something. The machine is supposed to, or the tool is supposed to. It can be weight. does this, I have 3 weighing machines, and what's the performance of each of them in being more accurately be able to detect the right weight, and you have some gold standard somewhere. Or you don't have even a gold standard. You just simply say there are 3 of them, which among them is better than the other. But when you're looking at prediction, it just simply says, what can I predict? I mean, this is a test. Otherwise, we do it all the time in our wards and say, okay, here's a sick patient who comes to me, and you have tons of scores which tells you, if I apply this score, it tells me what is the likelihood of this person dying during the ICU stay or things of that kind. So you must de-link prediction, because there are no gold standards for prediction. It's just
that's what
event, yes or no. But for diagnostic tests, you need a gold standard to say whether what is right. Okay, so this is simply, I put back what you said. So I simply happens to be the predictor. So exposures could be predictors, it could be an intervention like a drug, it could be a risk factor, it could be anything. But just as a concept, I want all of you to understand, it's an association, a relationship between 2 things. One is the outcome and something else. Something else could be a diagnostic test, it could be a clinical sign, it could be a demographic characteristic, it could be environmental character, whatever you like, but you're just trying to look at the association. So basically CIs are one set of variables which you're looking at. O, the outcome is another, and you're measuring to see whether there is any way to look at the...
Sir, just a little comment. The question, can you just go back to that? The question actually should say or, death or non-fatal MI. Because
I am not stating. I picked this from the journal. This is the title of, as you can
yeah,
see
but
here. This
since
is
we are discussing...
So, yeah, so no, it could be both. It could be or.
Because a patient who's dying will not have non-fatal MI.
Yeah, so basically what they're trying to say is and or.
Or.
And or. I mean, you could have an MI and die, and you could have an MI and not die. So basically these are 2 different... but just, this is only to get the thought through, right? So I hope all of you are clear what a research question should have. So this means you have done your brainstorming, you have got your thoughts in mind, you've decided what your question is, you have a basis, a rationale as to why should the relationship exist? Is there any basis for this relationship to exist, right? So once you've got that clear, then you say, okay, whom am I going to study in? I've already told you this. Whom does not mean only Homo sapiens, animals, cells, tissue, whatever you like to call it, okay? What are the variables I want to look at, whose association I'm trying to study, okay? So one of them you call the outcome, the other you like to call an exposure, predictor, whatever you like to call them, intervention, okay? So that is only the question. Unfortunately, this is not by itself entirely sufficient to be able to plan the research study. You need to go one step a little behind, because all studies have a certain degree of assumptions when we do. You know, you need to know, for instance, on the basis of research question, I can't quite decide how many people should I sample. Do I need 5 people? Do I need 100 people? 20 people? That depends to a great deal on my outcome measure, right? If, let's say, 80% of the population of women, the reproductive age group, have a hemoglobin less than 10, that is region A of the world. There's a region B of the world where they say that the same women in the reproductive age group, the proportion who have a hemoglobin less than 10 is 7%. Okay? So, where do you have to hunt for more women to get enough numbers to show there is 80% who are here or 7% there? You have 2 regions. You got the question? The population is slightly different in the sense, but the age groups are same. The outcome is the same, that's hemoglobin of less than 10. But the prevalence of the two are very different. So will it make a difference whether I use the same number of women? Suppose, let's say, 100 women I do here with 80%. What's the likelihood in 100 women I will get 7 women? Here we are saying if at 100 women, 80 of them should technically be anemic. That's what 80% is, right? There you see 100, and I should get at least 7 women. But it's quite possible in a population of 1 million, that 100 sample may be too little for me to be able to get 7. So there's a sampling method which has to go, and so therefore these differences in burden of disease or the magnitude of the problem we're trying to measure determines how much or how many people you need to sample. So therefore, a research question has not yet made this assumption. It's only asked the question. So we have to make some assumptions. And those assumptions need to be stated. And when we start doing that, we translate research question to hypothesis. So hypothesis is a statement, while research question is still a question. Right. So we'll understand where the difference lies. So what does it do? It can, a hypothesis identifies what is the predicted relationship between the two. That means there is some a priori knowledge that you have that this is what is likely to happen. For instance, I go back to my example of the drug that we used. So you may come up and say, okay, what's it? Based on some animal data and some pilot phase 2 studies that's available, you say that people who consume this new drug, we will be able to see a reduction in cholesterol by about 50% from some baseline value, while the standard therapy only brings it down by 25%. Okay? So what is that? So you're trying to say that this new drug seems to lower cholesterol more than the other drug. So you have a predicted direction in which you think it should go. That's your assumption. The study may turn out something else, maybe conforming with what you hypothesized, or maybe something else, but you began with an assumption that this is the way it's going to happen. So your hypothesis has that embedded, that there is a direction also. It's not just simply saying, is it better, is not hypothesis. Is it better, is only research question. Of course, the question can also be the other way around, saying, is it as good as? It doesn't always have to be something better. You can say, is this as good as this? Then you end up by saying that both are equally, there's no difference. That's the direction. You're saying there's no difference. So there are two ways to look at this. One saying that one is better than the other, and the other to say that both are equally good or equally bad. And those assumptions gives you the direction. So the hypothesis will then say, well, I don't expect to see more than 5% reduction, plus minus, both will be similar. They're not going to do great magic. Okay? And two, that these variables are testable. Okay? So, my liking somebody has to be put in a format which is testable. We simply say that I like somebody and those are all abstract ideas. They're very difficult to test. So therefore I have to have a method that is subject to a test which I can apply, the empirical form of testing mathematically. All right? So that's why these variables should be measured. So basically this is what happens. I'll give an example. You'll continue to see my bias as pediatrician, so it doesn't matter. So this was the research question. Okay? The research question was that whether, we clamp cords traditionally the moment the babies are born, and somebody says, no, let it be there. The rationale for that has been that a lot of blood gets transferred from the mother to the baby while the pulsation is still on. So it's okay, more blood to the baby, more hemoglobin, more iron, baby will be better, etc., etc. That's a rationale. So does this cord clamping at birth improve hemoglobin at 6 months in term neonates born to anemic mothers? So let's go back to a PICO. What's the P here? Sorry? First is term neonates. Mothers must be anemic. So there are two criteria you need to fulfill. All right. Okay, very good. You have an exposure. What's the exposure? Delayed clumping. And you have to define what delay is. 1 minute, 2 minutes, 3 minutes, or placenta, or whatever you like. And there's another traditional way that moment the baby is born, you clamp. Okay. That's your comparison groups. What's your outcome? Sorry? Hemoglobin. And in how much time? 6 months. All right. So you got the PICO. Now, can somebody make a statement of this? Which you have to say that what would happen if I do this, this, this. Can you just simply try to convert this? Yes, please. Is there a mic somewhere here? Okay. As a statement, not as a question. So reframe it. All right. So what you're saying is, just repeat yourself. Take the mic. Take the mic.
So, statement is a delayed cord clamping at birth improve hemoglobin at 6 months in term neonates born to anemic mother.
Very good. Is it good enough? Does it have sufficient details? So let me start with the population. Anemic mother. What's the definition of anemia? 10 grams, 11 grams, 9 grams, 8 grams. What are you talking about? So you have to bring a number there in that statement. So define what you mean by anemia. All right. So in women with hemoglobin less than something, all right, that's part of the mother. So you improve by defining what anemia. So hypothesis statement may now not just simply say anemia, it must state what is the definition of anemia. Okay. Term babies. Now, term babies, fine, that we all know, but we know that they can range from 1,000 grams to 5 kilos. So what am I looking at? So you may want to define the weight of these babies. Okay. So you say, okay, let me take normal babies, more than 2.5 kilos, something like that. So you have to go one step further and say, are we talking all babies, all weights, are we talking about certain weight? So your state, it must, because then the generalizability comes only to that population. Okay, so you need to be more specific. Okay, then we come to your intervention and you say delayed cord clamping. So you have to say, what is delay? You have to define what this delay means. 2 minutes, 3 minutes, 90 seconds, whatever you like. So you have to say delayed cord clamping beyond a certain time as in comparison to when, let's say, cords are clamped within 30 seconds. So you have to be able to define both the interventions, right? And you have the outcome hemoglobin. How much will it improve by? Do you expect how much? 1 gram, 2 grams, 3 grams, whatever. This comes from some literature review, some animal data, whatever you do, that is maybe a guesstimate from some pilot studies you did. But you need to have all this. Okay. That means the quantum of the outcome that you want to measure also has to be part of the hypothesis statement. Okay. So if I was to, so would you like to now restate your statement? Having discussed all that, what it may sound a little better than what you just now did. Time is already defined. So okay, we have discussed so much. Can you just put this all into words and say this is what my statement says? This is my intent. What I'm going to do is this. Yeah, anybody? We have had so much discussion. So just put all what we discussed into a nice statement. And you have the hypothesis there. Yeah? Go ahead. Okay. 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 In comparison to when you clamp cord at something. So instead of, it is nice to still follow the PICO and still in your statement bring the population first and say you can reframe and say that women giving birth to term babies more than 2.5 who have a hemoglobin of less than 10 grams would have their babies having a hemoglobin of more than 2 grams if the cords were clamped, say 2 minutes later as compared to if they were clamped within 30 seconds, something like that. Right. So you got all the elements. You got a little more clarity on what your population is. You got clarity on your outcomes. And the critical part is this measurement. You now say, I want to look at this 1 gram or 2 grams hemoglobin. That is going to determine what kind of sample size you're going to look at. Right. So this is just to make you understand that these are critical parts of hypothesis testing. Right. Okay. So what it looks like. So we said non-low birth weight, but I think your definition is better because you don't leave it to somebody's imagination. You end up by saying in term, babies more than 2.5 kilos, born to mother, hemoglobin less than 10 grams, caught clamping after cessation of pulsations when compared to clamping immediately after delivery, increases HB by 2 grams at 6 months. So this will then help you. See, once you do this, life is very easy. This is the toughest part. Once you have done this, then rest of study design is very, very easy. Because then what you have to do? What kind of a design I have to do? And once you got the design, then you have no choice. It's a tight silo. You just simply follow the rules of the game. I always say that most of the study is already over. When you write your protocol, the study is over. You even have your boxes for results. खाने बन गए हैं, उसमें सिर्फ numbers डालने होते हैं ना. तो आपको पता है क्या ढूंढना है? क्या चाहिए? You got all that information. You know what to collect. You already done that exercise. Rest of the study is only collecting the data. Put the numbers into it. Put in a computer. Get your answer. This is the hard part. Getting to write these 5 lines is the toughest part. This is where the intellectual input comes in to create this clarity of what this is. So when we always look at, I always sit on all these committees looking for funding. First thing I look at is, does the investigator have that clarity of mind as to what they want to look at? You know, everybody says, सब कुछ करना है, ठीक है, सब कुछ नहीं हो सकता, सब कुछ, too much of noise. You need to remove all those noise and come back to the point that you have, right? So please remember, this is the most important part of your work. So once you're able to do that, okay, fine, I've got a nice statement, very nice. Next part, can I do it? That's a bigger question, okay? You come down, you first began with some idea, you said, nahi ho sakta, nahi ho sakta, and then you finally came and said, Hanji. This is an unanswered question. So you from that unanswered question, research question, you got a very good hypothesis. Now the question is, can I do it? So that's the important thing. So you need to put this next in. Is it feasible for me to do it? Feasible in terms of time frame, feasible in terms of the clinical material, will I get that much? Right? या RML में नहीं तो मेरे को सब जंग भी LHMC सबको जोड़ो तब शायद मरीज आ जाए मेरे पास. Right? Do I have the equipment to measure something? So all those questions, the feasibility depends on all those. So is it possible for me within my time frame to do all this? All right. Is it interesting? Of course it's interesting. That's why you're doing it. Otherwise, why would you do it? Well, you do it, whether it's interesting to you or not, is interesting to your guide. So it's interesting to somebody who's part of the research team. All right. So it is obviously somebody's interest. Is it novel? Now, remember, novelty has many ways to look at. Somebody may say, are there anybody from obstetrics here? OBGY? No? All right. You know, there's been this debate going on for a long, long time. What is gestational diabetes? So, you have some X society's definition, some Y society's definition, a third society's definition. Question is, all this is some blood sugar value, some fasting, some postprandial, you give some glucose loading and then come up with some number at 2 hours. End of the day, the question is, I'm a clinician. Tell me what's it going to do to the mother and baby? Does this, if one definition, the cutoff is 5 milligrams higher, another says 15 milligrams higher, तो क्या फर्क पड़ता है? Is it going to make a difference? So the point with the novelty here lies in saying that, is there a different way to look at this whole exercise and not just run around numbers and say, does it make a clinical impact? So I'm redoing the study, not looking at what is gestational diabetes, by saying, okay, let me look at, okay, all these women classified as gestated by all these criteria. I'm going to follow them up to say what is happening to them in terms of maternal outcome, in terms of newborn outcome. And then I will come back to you and say, okay, is this correct or not? Or do we need to even revise all this and say this is no good? I need to have a completely different definition of what you call gestational diabetes. That's what causes biological changes. You must have sufficient hyperglycemia for sufficient duration to be able to cause a clinical impact. So, so those kind of things. So novelty is not just looking at this, it's also looking at the same problem in a different way is novel. It's not that everything is unknown, but there's a new way of doing it. It's ethical. That's very important. We're dealing with humans, so therefore there's a lot of ethical issue. Somebody from pathology may say, sir, what is ethical? I've got a sample. Another tissue, can I stain you with GIMSA? Can I stain you with immunofluorescence? Is there any ethical issue do you perceive in using a histopathological sample? Do you need a consent? Is there any ethical concern? So let me ask all bright young people here. This is a very, today, anything today, everything is the morality of what I do in biomedical science is always put on a question mark. So let me ask you, if I'm using histopathological samples, is there anything unethical if I just simply take samples and do research? Do I need to get consent? Yeah, come on. As medical scientists, this is what we have done now to the new curriculum. The new undergrad curriculum has a huge stuff like this starting from first year. The dialogue is about understanding what is right, what is wrong, what is moral, what is ethical, what is not ethical. To me, these things are just as important to understanding medicine as the hardcore subject. All right. So let me give you the answer to this question. Now let me ask, sir, what's your opinion? Histopathology sample में कोई टेस्ट करने के लिए कोई is there an ethical dilemma और आपको लगता है कि हमें कुछ नहीं करना चाहिए? Can I have that mic so you can use this? You can sit down. I bet here. Huh?
If there is a diagnosis is written on the paper, it will have psychological impact on the patient. And number one, number two, about the publicity of whether it is made to be made public or not to be made public. So these are two things which come to my mind.
Very right. You see, when a patient comes to us as a patient, there's a fiduciary relationship between the patient and us, wherein I am morally or otherwise bound to keep that information confidential so that only the two of us share. It's not for, as you rightly said, it's not for public consumption. And there are issues about what I should do about it. Obviously, I need to do something, even if I have to share. It needs to be kept confidential. There are some identifiers of the patient that needs to be kept aside. So the difference between research and a patient just walking into my outpatient or hospital is that research is something I'm driving. Patient didn't come to me asking that. But as Dr. Saab said very correctly, we are going one step ahead and saying, I want to utilize the information I've gathered to you to be put into larger good where a lot of people will know about your information, but without knowing who you are. That's the critical part. And therefore, when we are taking a consent, we are saying, I have a sample, but these samples will be tested, but who you are will not be known. So I'm going to ensure that your identity is kept out of this whole public domain. You have 100 samples and you don't know who it is. Unka naam nahi pata, tumhe unka address nahi pata, kaun hai, so you don't know. You may of course know the gender, you may know, but you don't know from which part of the world you come. So there is an issue about this. This becomes even a bigger problem in the field of genetics. Right? People have argued that I have a sample, मैंने इनका sample लिया इसके लिए मैंने स्टोर करके रखा है 10 साल के बाद इस बीमारी का somebody has found what is the mutation, so I want to use it. Can you do it? The answer is no. So remember, any sample that is drawn for a specific purpose. If I'm saying I've given a sample as a patient, come to you, I'm supposed to get 3 reports out of that. It's meant for that and meant for me and not meant for anything else. Number 1. 2, if I've drawn a sample for a research which does not have this futuristic genetic essay in my mind as part of my consenting process, I can't store it and use it. However, I can build it into my consent and say, I am taking the sample from you today, but would you allow, and there are 2 parts to this. 1, you give consent for the present study, and 2, would you also be willing to allow your stored sample to be used for genetic testing as and when we gather some future genetic information? For those who say yes, you can store it. Those who say no, it's out. Because 20 साल के बाद you can't chase the मरीज and say कि भैया कहाँ थे तुम्हारा sample मेरे पास पड़ा है, please मेरे को consent दे दो, नहीं होगा. So there's a method. So please remember that there is an ethical issue that you need to understand as part of your work, and so the way you frame your consenting process is very critical. Relevant, it has to be relevant to, current time, this health problem. But there are some areas of basic science where there's no relevance immediately visible to me. A lot of people work in basic science labs looking at what is happening. उसका फायदा होगा कि नहीं आज नहीं पता. हो सकता ना हो, लेकिन it's also important to understand the mechanistic issues that happen around it, because that may throw some light in the future. Today I don't know. So while a lot of research that we do in biomedical science, in clinical epidemiological science, is we talk about relevance, public health or other relevance, there's a human good to it. But there are branches of basic science where today I don't know the good, but I work in the hope that my attempt to find a mechanistic answer to why this leads to this may in the future be useful. Somebody may come up with a diagnostic test, somebody may come with a therapeutic answer. So there's a relevance to it which you need to put forth. And so this is what we call FINER. So 2 acronyms you need to remember at the end of what I've said. One is the PCOT, that help you frame your research question and the hypothesis. And then FINER, to say what fine-tuning do I need to do to improve. If I don't have, as I said, resources, then find ways and means. Is there a way to do it? Is there somebody else? I don't have it. Maybe INMAS has some nuclear stuff. I collaborate with INMAS. I collaborate with XYZ institution, which has. So there's a collaborative. So you can find a solution for everything, right? So if you don't find the solution, Then you say, okay, this is the gold standard test today, लेकिन ये available नहीं है, मैं उसका next best लेके करता हूँ. That's okay. That's the way it's to be done. So those are questions you need to ask. So remember, this finer will help you fine-tune finally and say कि question हो गया, उसका hypothesis हो गया, doability भी answer करना, then you're ready to launch on to writing your details of your study, your protocol, and then say, okay, I do some data collection. Okay, so I think that kind of sums up. Okay, this is just to some examples of what I've just now said. So, what all happens. So is that clear to all of you? How a research question is to be framed, and how the hypothesis is to be stated, and then run this through the finer sieve, the mesh of finer, and then with discussion, find kya ho sakta hai. Once you sorted that out, that is what gets translated into your final protocol, because the protocol is what is doable, right? Protocol. So of course the protocol goes to an iterative process in most places. There would be, you sit with the guide and write something, the guide says, ye nahi ho sakta, isko modify karo. So ek level pe finer gets modified. फिर एक departmental committee होता है जो देखता है, then it says ये doable है. Then there's another level at the institution level. So at many levels you will go through till your final study through several iterative processes get sorted out and say, okay, now you're ready. This is how you're going to get going on this. Okay. So once you do that, then writing the protocol is relatively easy. I'll do the next session what the design is. And once you know what the design is, rest is written. So but data ही collect करना है. So ये सवाल हमेशा पूछा जाता है कि जब मैं पेपर पब्लिश करता हूँ, इसका guarantor कौन होता है? Who should be the guarantor? Should it be the person generated the idea? So there are people who contribute to the intellectual content of the study in terms of generating the idea, planning. Is it the person who's actually collected the data? Is it the statistician who's done the analysis? So what in your opinion should be, who should be the guarantor for a manuscript at the end of a study? Yeah?
The one who conceived the idea.
The intellectual input is the most important. Remember, rest तो कोई भी कर लेगा, क्योंकि data ही तो collect करना. So remember, the intellectual content is very critical. Statisticians also become part because, remember all good studies have study involved right at the beginning. They also put their intellectual input into the design issues and sampling issues and number of samples and what tests. They also have a role. So ideally, all those people who put in, and if you look at all manuscripts, they'll ask you, आपने सारा fulfill किया है, तब author बन सकते हो. सिर्फ आपने data collect किया है, या मैंने इसको बैठ के type किया है, not sufficient to give you the authorship. Because anybody is an author means they've all put in their intellectual input into that. Okay, so I'll put a stop to this. And you people, when you get back to writing your thesis, I hope you will start using those principles to generate the. Okay. So if you are okay, then I go on to the next part. Can I go on to study designs? Yes, Vijay.
The question is that, yes, if there is a distinction between interesting and non-interesting, yes, to that extent it is acceptable. But when you go into interesting, more interesting, very much interesting, it adds some element of bias. And I also see that, recently in government, they have also added that so many, publications are essential for you to get promoted to the next grade. Now that also makes me interested. Now, interesting and interested, there's a very fine,
Obviously, the subject has to be otherwise, why should I waste my time writing a thesis? Nobody would say. not going to get into that because that's a completely different domain. So let me restrict myself to the issue of doing the research. So I shall not answer that. The roles and responsibility remains the same. Everybody who has been listed as an author is guarantor, and they are all equally responsible. It doesn't make a difference whether you're the first or the last name in that list. Remember, every name that appears there on an authorship list is just, as far as I'm concerned, equally responsible. Everybody is. That's why all of you sign. All the authors sign that I have read this manuscript and I put in my whatever, etc., etc. So we all stand guaranteed. So everybody is a guarantor. Of course, there's somebody who's more principally involved. There's somebody who's put in intellectual input. But anybody who's been granted the authorship, it is assumed that all of you are equally. So you can't say, मैंने सिर्फ इसका lab test किया तो मेरा कोई responsibility नहीं. Well, as I told you, I don't want to get into this dialogue at the moment. But I just wish to say that when you do research, everybody who is going to be publishing that work has equal responsibility. It is not just one person. You can't say everybody has a role. तो laboratory वाले का भी important है. तुम्हारा lab data गलत है तो some data is going to go wrong. जिसने वजन लिया उसका भी important है. यदि वो he's got other characteristics. So everybody who's listed as an author has a role. So nobody, I don't want to say anybody is less important. Everybody is equally important. Right? So
When do you use null hypothesis?
that tomorrow Dr. Pandey will talk. So I'm not going to. Let me go back to the. Let me just go to the design issue. Okay. So now that you've got your research question ready, and we need to know how do I go about it? What kind of a design do I need to do? So just look at this. These are the kind of broad generic questions that we keep asking biomedical research most of the time. You either want to find out what is the magnitude of the problem or what's the burden of disease. है ना? जैसे मैंने वो अनीमिया वाला कहा, कितने प्रतिशत लोग हैं जिनको अनीमिया है, कितने प्रतिशत लोग हैं जो obese हैं. This is just asking a burden, right? How many have hypertension? So you're asking for magnitude. You say, okay, what is the prevalence of HIV? So these are all just asking a question about a burden of something. This is one set of questions that you will ask, and when you read, आपको ये मिलता रहेगा. दूसरा, you want to know what are the characteristics of people, right? If I was to look at this room and say, okay, characteristics, and then you classify them saying, okay, age distribution ये है, उसका gender distribution ये है, कितने लोगों के लंबे बाल हैं, कितने के छोटे हैं, कितने के कान में छेद है, how many males wear earrings, how many females don't wear earrings, etc., etc., etc. So it tells you some profile of people, right? That's the next kind of question you ask. The third thing you're asking is, if there's an outcome or a disease, उसका कारण क्या? What are the risk factors that lead to this outcome? Right? It could be death, it could be disease, whatever. There's an outcome issue. Then what is the likely outcome to an exposure, specific? मैंने एक दवाई दी, बीपी कम होता है कि नहीं? ये बीमारी होती है, तुम जियोगे, मरोगे, death, living. So that's the kind of, you're asking that. Then you have treatments. You have various treatments. I want to know, is one treatment better than the other? So you're asking this question all the time. And then there's the issue about how good is something for diagnosis. You're talking about laboratory tests or tests, variety of tests that can use either for diagnosis or prognosis. So bulk of questions that we are asking in biomedical science, I would say 85 to 90%, would fall within these set of questions that we ask. And so therefore, I'll come back to saying so remember, if you can remember this, and when you do your study, just say where does it fit in, and at the end of this presentation, I'll say for each of these questions what designs will happen. Then it becomes very easy. if you can understand this slide, I think you need nothing more. 90% of designs are all here, right? So I'm going to run you through this, and this is the key part that you need to understand. So you're the investigator. So you have an exposure. So you're going to ask this question: am I going to assign the exposure? Am I going to decide कि तुम्हें कौन सा exposure होने वाला है, मिलना चाहिए? If I'm doing that, the moment I decide you will be exposed to this, she will be exposed to that, the exposure is under my control, that means I'm experimenting straight away. So the first question, the moment you say that the investigator is able to assign the exposure to one or the other person, then you're in the realm of experimental designs, which can be either randomized or non-randomized. So just that's one. That's the easiest part. So जहां आप ये सवाल पूछिए कि जो exposure है वो क्या आप assign कर रहे हो कि नहीं. यदि आपका जवाब नहीं है, which is the case for all non-randomized controlled trials, means we are now doing observational studies. I'm not tampering with anything. जो चल रहा है, मैं सिर्फ उसको observe कर रहा हूँ. Then you need to ask a question that if I'm not assigned the exposure, I'm in the realm of observational studies. Am I making any comparisons or no comparisons? Right. I simply want to describe all of you sitting here. I'm doing no comparison. I'm just collecting this information. Census operations, there is no comparison. Simply collect data. You're just describing people. That's in the realm of descriptive studies. So descriptive studies have no comparison. And when you have no comparison, there's no analysis. Okay? But descriptive studies do measure some incidence or prevalence, so therefore there is an issue about sample size there. But just remember that there's a descriptive study where I'm doing no comparisons. But then I may be doing comparisons. Those observational, I may want to compare. I may want to compare some group versus something else. You have broadly 3 ways by which observational studies can be categorized for the purposes of analysis. The first is outcome has not yet happened to any of the subjects. Some have had the exposure, some have not yet had the exposure, and I just follow them up over time to see what proportion of individuals have the outcome in various exposures. And these are natural exposures. That's your cohort. A cohort study simply has, let's say somebody who lives in an area which is high in fluoride content of water, somebody living in another area with the fluoride content low, and you have, it's a natural occurring phenomenon, you're not doing anything. इस गांव में जितने भी लोग हैं, this whole village and this population becomes one exposure. There are people living 100 kilometers away who don't have this, and you just want to look at what the effect of this high fluoride intake on some outcome. So you just keep following them up. And of course the assumption is that individuals who already have the outcomes in those populations are out. So you only follow the rest. So the exposure is happening or will happen, but outcomes are not yet known. So that's a cohort. So basically these are longitudinal studies. You start from exposure and keep till the outcome happens. Cigarette smoking and lung cancer. People are smoking, some are not smoking. You're not deciding, उसको ये थोड़ी कह रहे हो कि तुम smoke करो. जो कर रहा है वो कर रहा है, और जो नहीं कर रहा है वो नहीं कर रहा. So you just follow them up. Follow them up 15 years, 10 years, whatever the time plan. Say how many will develop lung cancer. So you will get a certain proportion of individuals among smokers who will develop cancer, You get a certain proportion of people among non-smokers get cancer, and then you do some statistical analysis to see इसमें कुछ फर्क है कि नहीं. The second is people who have got the disease. Disease हो चुका है. I want to go back and ask whether you have an exposure. So I select some people, let's say who has got lung cancer. I select some people who don't lung cancer and go and ask them, बताओ तुम्हारी स्मोकिंग हिस्ट्री क्या है, कितने साल से स्मोक कर रहे हो, क्या क्या प्रकार के सिगरेट स्मोक करते थे, रोज कितना करते, एटसेट्रा एटसेट्रा. ये दोनों सभी में पूछो. And then you are measuring, is there a difference in the exposure? In the first one, what you are measuring? You are measuring the outcome. You are saying, ये outcome और इस outcome में कोई अंतर है. दूसरे में आप कह रहे हैं कि outcome तो मेरे को पता है. You are into my study because I've selected you on the basis of outcome. Now I'm asking you to tell me your past life and tell me what has happened in terms of exposure. So case control, remember this is another problem I have a lot of you. Anybody control hota so case control bana dete hain. This is a common problem I have with most theses. A case control study is an epidemiological observational study where the subjects have been recruited based on whether you had or did not have the disease. That's the first, that is what the case control is. I think this term case control creates a problem. So basically, you can say disease and non-diseased group or whatever outcome or no outcome, but a case control bias is not just because I have some comparison group, it doesn't become a case control. It's how you select people. The third is both outcome and exposure. I'm not selecting anybody on the basis of that. Okay? I decide to go to, let's say, Sabji Mandi, select all the people, and I measure their blood pressure and record the BMI. I want to look at what's the association between BMI to hypertension. So I have a definition of hypertension, I have a definition for your BMI. ठीक है, obese कौन है नहीं है, सबका दोनों साथ साथ मेजर करो. किसी को मैंने एक्सपोजर या आउटकम के बेस पे सिलेक्ट नहीं किया है. I select everybody. That means at one go, cross section. So when people are selected neither on the basis of their exposure nor on the basis of their outcome, but both probably exist in all of you, and I measure both of them concurrently, not back and forth. These are all cross-section studies. So just remember, the three things, the simple definition. The simple definition is, how did this patient enter your study? I entered because of exposure without the outcome, and I follow you up, cohort or longitudinal studies. I entered this study because I have the disease or no disease, and I've been asked, or my exposure factors were then probed into case control. I invited all of you in a certain age group to join me, and then I measured both exposure and outcome, both the variables simultaneously. Then it's cross-section. Is this clear to all of you? So essentially, you have five things. Either you do a descriptive study, so many of us do, just describe people in some population, or I am doing an analytic study in observational mode, which can only be three: cohort, case control or cross-sectional. And third, I intervene as an investigator and create an experimental design. So I have a randomized control trial. I mean, it can be, you can randomize animals, you can do randomized control trial in labs also, right? Whichever way. So broadly, 5 broad major trial designs, study designs, should answer more than 85% of all your questions which I posed to you earlier. Is this clear to all of you? This, just get this etched into your mind. This is the one slide. Uske baad life becomes fairly easy. So we'll very quickly go through what are these issues, designs. So how does descriptive studies help us? They give you a general idea कि हो क्या रहा है, ठीक है ना? You look at census data, very useful. you have state-wise data, you have district-wise data. It helps planners design kya ho kya raha hai. What is different, right? Is there something different about this? You have different communities here, you have different levels of impoverishment, you have malnutrition, so many things that happen. So you can map regions, they're all from descriptors data, but it helps people to understand what's happening or kahan kuch karna. Why is there so much malnutrition in X area? Why not in this area? Look at UP, for instance. UP is like another country. You have variations running from the eastern UP to the western UP, swings across. But then it helps planners to decide कि यहाँ करना क्या है. So descriptive studies help in giving some kind of idea कि what's happening. It's like a big canvas in which you understand what's happening. It may also, descriptive studies are also, for example, case reports. 1, 2, 3, 4. They're also descriptive. आपने कुछ conclusion नहीं किया, आपने एक describe किया कि एक मैंने इस मरीज में देखा है, फिर आपने देखा, अच्छा, I see some problem. I said, कभी किसने देखा नहीं. Then I review literature. अच्छा, somewhere in Venezuela, some person also found a similar finding, and they said this is the likely cause. तो बहुत अच्छा, तो मैं भी वो investigation करता हूँ, फिर find out that वही है. We build up a second case. Like that, a whole series develops. You're describing. You've not done anything else. You're describing. You're not doing any comparisons. A time may come where you may develop either a new diagnostic test or a treatment which you want to test, but then, or you may want to do understand what are the risk factors, but it helps you understand ki ho kya raha, what's happening, right? Descriptive studies don't give any kind of relationships, but it's just simply telling you what's happening. So there's no relationship. They're very good because they actually generate a lot of questions. They generate a lot of questions. So, when you look at, let's say, the census data that's published, let's say health में, so you say, इस area में TB बहुत ज़्यादा है. MDR TB is more in a given region of, say, Madhya Pradesh, while on the other hand, some portion of Tamil Nadu, very, very low. So you want to know why. What is it that's different here that we have so much of MDR here and you don't have so much of MDR here? Because understanding that may help you understand how to prevent more MDR in regions which are high. So you plan a study. So it generates questions. So descriptive studies help you generate more hypotheses. Okay, this is just an example. This was somebody described. This was published many years ago in 1990. Primary cause of neonatal deaths in a tertiary care hospital. Autopsy of 331 cases. So what do? They just describe. कितने बच्चे मरे हैं, कारण क्या था, क्या reasons था, you get a description, okay? ये malformation कितने हैं, asphyxia कितने हैं, all this. So you get some kind of description that helps you. And then if you find that this description in some region is more, your antennas go up. If not yours, well, there are people who are watching in surveillance. Somebody in the health department decide this is not good. Why is one outlier? Why is somebody behaving so terribly badly? All right. Kerala is a great example. Everybody asks question, why is everything so low in Kerala? Why is mortality so low? Right. So you can do all the studies. Everybody comes to a conclusion that it has to do with women's status, to do with education. Very good. So that is the key reason. Well, that's not something the health department could do. That's part of overall social development. So you push the agenda to saying, how do I bring equity? How do I bring equity? How do I get more people educated? How do I get women's empowerment? So things like that drop up, and then you decide what is to be done. So this is what descriptive studies do to you. And let's look at cross-section studies. As I said, what are cross-section studies? It's done at a single point. Simple. One goal. At least for that person. उसको एक ही बार आपने मिलना है, उसी टाइम आपने जो कुछ उसका टेस्ट करना है, मेजरमेंट करना है, सवाल पूछना है, एक ही बार में खत्म. उस मरीज के लिए एक ही कांटेक्ट. हर एक के लिए अलग अलग है. Then you gather over time. But for that person, he doesn't have to show his face again to you. All right. So you have measured both the outcome, this exposure and disease status together, not over time. What it gives you is prevalence. What's the difference between incidence and prevalence? Yes? Gentleman, white, with a beard. Yeah, you? What's the difference between incidence and prevalence? Right? So incidence talks about new cases, prevalence. And since when I measure at one time, I don't know new cases have happened. I only have the total burden. So these cross-section only give you prevalence. It can't give you incidence. For incidence, I must follow up a set of people and see what happens. Right? So that's the reason why you will get this, you will get some answers here. Right? So here are some advantages and disadvantages. Well, anyway, I won't go into that. Just to say that they are fast, inexpensive. You can do quick surveys, get some answers, helps planners, get some answers what's happening. Okay? So there's no risk of loss to follow up. You can do some association studies. After all, you have some variables. You have plenty of variables, so you can say whether there's an association or not. You may not get a causal relationship, but you can say there seems some association. And if you want to retest whether association exists, you can do a more formal, well-planned study to get that answer. But it gives you some kind of an idea ki, what is happening. Right. So here it is. So here is a question. This is from some paper that what effects do attempts to lose weight have on the observed relationship between nutritional behaviors and body mass index among adolescents? Right. So we go back to our PICO and we see that the P is adolescent school children. So you define who your adolescent school children are. Exposure, as you saw from the title, is you are going to ask some questions about eating habits, their physical activity. All right. Outcome is BMI. Okay. So if I go out into a community of adolescents, select them all, I'll measure the BMI now. फिर बैठ के कुछ उनके feeding, eating or physical activity के बारे में on some standardized questionnaire, I gather some information, and then I can draw some conclusions that इन दोनों के बीच में आपके खाने से और BMI या आपके physical activity और BMI का कुछ relationship है कि नहीं. So I can do some analysis to get some idea. Okay, so cross-sectional studies can provide you some interesting relationships. The second broad is the case control design, right? So what happens? Okay, so you have selected somebody based on disease. You selected somebody as no disease, and remember we are moving backwards in time like this. ठीक है? तो जितने भी लोग हैं जिनको आउटकम हुआ है, उनमें से find out how many had the exposure, how many did not have the exposure. Similarly, the so-called no disease group or no outcome group get the answer as to whether they had. So you are getting the proportion of exposure among diseased, non-diseased, or those with outcome and those without outcome. But this is what we are doing in a case control. Okay. So, if you have a question, what does maternal use of loratadine in pregnancy do to causing hypospadias? An association, right? So, in a case control, what you do? You obviously, because hypospadias, it has to be all the boys. So, who are your cases? Boys with hypospadias. Boys without hypospadias are your so-called controls, right? The outcome is hypospadias. Then in each group, go and ask the mothers. Did you have loratadine? How much did you have? How long did you have? And so on and so forth. You get that information, exposure. And you can do a calculation. What do you calculate? So how do you represent this information? So the way to represent all this information is in this 2x2 table. 2x2 table, remember, is the core of any epidemiological analysis. ये आपको हर जगह याद करना है. जहां भी आप देखो ये 2x2 टेबल को कुछ भी कर सकते हो. डॉक्टर आरती आसिस क्वेश्चन नल हाइपोथेसिस क्या है, वो भी एक 2x2 टेबल पे ही कल आप डॉक्टर पांडे विल शेयर विथ यू हाउ दिस 2x2 टेबल हेल्प्स यू इन डिसाइडिंग कि वो हाइपोथेसिस को हम एक्सेप्ट कर रहे हैं, रिजेक्ट कर रहे हैं, क्या है, वो भी 2x2, एवरीथिंग इज अ 2x2 टेबल. So remember, disease, we are starting from exposure to outcome. So when you construct your 2x2 table, always make sure that your exposure is on the y-axis. Here, this is exposure. And on your x-axis above, so your rows are exposure, your columns are your outcomes. Okay? So you put your values. As I said, there will be always, if you're looking at yes, no for exposure, yes, no for an outcome, there are 4 possibilities, isn't it? It comes to 4 boxes. And you put these values there. Call them A, B, C, D. So what is A? What is A? Those, since you're talking about case control, so we'll work the other way around and say, these are those who have the outcome and also the exposure. So all those who have the outcome and also have the exposure of interest. Okay? What is your B? Those who did not have the outcome but yet had the exposure. And C is all people who had the outcome but did not have the exposure. And D are those who did not have the outcome and did not have the exposure. Okay? So essentially, what therefore is the proportion of people who had the exposure among the people with outcome? Sorry? A upon A plus C. So if you look at the proportion of people amongst those who have the disease, you can say A upon A plus C, or the proportion or the exposure. And if you want to get that proportion in the controls, it's B upon B plus D. Now the one problem that you have here is that you actually did not have the entire population who had the exposure or no exposure. This is only those with disease and no disease. You don't know what the universe was there. And so it's very difficult to utilize this proportion of people with and without the disease having no exposure as a basis. And so, which is how we calculate risk. But since we don't know all of them, you end up by calculating something called the odds. Odds is the probability. You can talk about A upon C, but you can't actually talk about A upon the entire A plus B, because you don't know what the entire population of people who are exposed were. That was never available to you, because you only sampled those who had the outcome. And you also do not know the entire C plus D. So you cannot calculate risks. So we calculate odds. So in case control studies, you always report what's called odds. Right? And that formula is there. I'm not wasting my time, but just to let you know, you must know the difference between odds and risks. Odds is a probability. It's like saying, what is the probability of, you keep reading in the paper all the betting that they keep doing. Or Chennai Kings versus somebody else, kaun jeetega. This is all odds. Betting is all nothing but odds. They are not calculating risk, they are calculating odds. Right? It's event to non-event. It's not event upon all events. That's the difference in odds and risk. Risk looks at an event across everything. But when you look at the ratio of event to non-event, then you get something called odds. And this is what they do in horse racing and everything. And so all the bookies are very good at this exercise of calculating odds and probabilities. They're doing it every day. So remember, this is just to get you home that this is how your data set will be plotted, and what you will report is odds ratio for a case control and not risk. Okay. So if you plot this information, just to show you what it means. So this is what it looks like, and you come up with a figure which says 1.2, which means what? The probability of having a hypospadic baby, having a mother who had loratadine, is but 1.2. If you looked at risk, it will say something like that. So here we are looking at the probability of the exposure having happened amongst individuals who have the outcome. ठीक है? It's okay. यदि मेरे को ये किसी को कहना है, यदि कोई माँ आके मेरे से पूछेगी कि मैंने दवाई खा ली है, मेरे को बताओ कि मेरे बच्चे को हाइपोस्पेडियस होगा कि नहीं, तो यू एंड अप बाय सेइंग ठीक है, थोड़ा 20% रिस्क है, तुम्हारा 1.2 है, वो स्टैटिस्टिक सिग्निफिकेंट है कि नहीं अलग बात है, बट द वे यू इंटरप्रेट इज थोड़ा देयर इज अ स्मॉल higher risk, but whether that's really statistically significant or not is a different story. But that is what it more or less kind of tells you. Small up, there's a slightly higher, but we'll check that out. The real challenge in case control is not selecting controls. वो तो सबको is not selecting cases. वो तो बहुत आसान है कि तुम्हें disease है, मैंने कर दिया. How do you say the other person did not have the disease? That is a very, very big challenge, especially in cancer. Okay, you got cancer. How do I say that you do not have subclinical cancer? I must have some kind of a test to say that you should have or should not have. So the selection of controls or the so-called non-disease subjects, or those without the outcome, is the most difficult part in case control, which requires very good description, right? For instance, if you know there is something highly familial, you can't have a family member as a control. हो सकता है उसका incipient हो, वो disease बाद में आए, 1 साल के बाद, 2 साल के बाद, तो क्या होगा कि if everybody there has like this, the person who doesn't today have the disease likely, then you end up by saying कि दोनों के characteristics अलग हो ही नहीं सकते. किसी को आज कैंसर हो रहा है, किसी को 3 साल के बाद हो रहा है, किसी को 4 साल के बाद हो रहा है. But then the difference becomes nullified. So you really have to be sure the other person doesn't have the outcome. That means you'll have to be able to conduct studies with a certain degree of certainty to be able to rule out the presence of the outcome on the so-called controls. So just remember this. So this is a very important way to remember this. The rest is, of course, how do you have defined exclusion criteria. Sorry? Because incident cases are the new ones. Otherwise, we don't know whether the other ones had it or did not have. Did they have other factors? No. I'm talking about here. If you look at it from, we are looking at an ideal scenario and look at a population. So you should ideally be able to say that this is a new case and not an old one, right? It depends on the kind of question that you're asking. Because it can vary. No, it's not necessary. We are only saying that there is a potential for bias. We are not saying you should not take them, but Ideal would be if you could have only these fresh ones, never been probed, then it may help you. But it doesn't matter because it depends on what your question is. G. Sure. These is to be cross-sectional. Same person is being, see, remember, cross-sectional means that individual is going to be seen only once. Which one? Give me an example. Very good. You tell me. Tell me. You tell me. So number one, not cross-sectional. So this individual has had more than one contact. Okay. It's going again, longitudinal. So it's not, that's why I said the cohort, it's not cohort, but it is still longitudinal. So cohorts and longitudinal have similar connotation. That means अभी outcome इसका हुआ नहीं है. आपने पहले कुछ किया. In your case, you're simply you're measuring albumin before what? Okay, and then so now here it is an intervention. Doesn't matter. It's an intervention. You may not have your own comparison is me. I am my own control. I have a value before treatment, I have a value after. So it's a single arm interventional trial looking at pre-post. Is experimental because I have given, but I don't have randomized because I am my own. There is no other comparison group. The comparison is me, albumin level before and after intervention, right? So I am my own control, I am my own intervention, so before and after. So it's a single arm, pre-post kind of design, and pre-post have a different way of analysis, though the designs will be in experimental group only, except that you will say it's a single arm. See, once you say single arm, there's no randomization. Single arm pre-post interventional design. It's a pre-post. It is experimental. Of course, it's experimental. Yeah. Okay. So, the first thing is your comparison is BP measured by two different instruments. Okay, so you can treat them as your so-called exposures. The BP apparatus is the exposure in a way, right? कि इससे measure कर रहा हूँ, इससे भी measure कर रहा हूँ. Now, you need to the longitudinality of this can still happen in experimental designs. So, yeah, I know, but you're comparing. Why do you want 6 months, 4 months, each could be treated as one measurement? Do you believe that this value has got a bearing on the other? If it doesn't, then they're like 3 different studies which has nothing. They may cross-sectional. Because abhi मैं एक measure कर रहा हूँ, इसको measure कर रहा हूँ, cross-sectional. On the other hand, let me give another example. Anesthesia. I want to compare 2 drugs for induction. Okay? And I'm going to measure, let's say, their blood pressure or their heart rates sequentially every 10 minutes for the next half an hour. Alright? Now, remember that you do not know what the initial heart rates of these 2 were. and the initial heart rate will affect the second reading. The second will affect the third reading. The third will affect the fourth, and so on. No, it is longitudinal. So it is, you have a randomized study. You can randomize somebody to get treatment A and treatment B. I'm not making one measurement. I'm making multiple measurements. So while the study is like an RCT, but at the stage of analysis, it will be different because you've got many outcomes. And outcomes where each previous outcome is in some way going to influence a subsequent outcome. So Dr. Pandey can answer how to do an ANOVA for what's called ANOVA for repeated measures is a method of analysis that we would use in such cases. But the first example you did is only one. If you don't believe that this has anything to do with what happened 6 months, you're just simply taking two blood pressure instruments, checking how much difference they have. It's one time. अभी इस हाथ से किया, फिर दूसरे मशीन से किया, I get, and that's about all. Yeah. There is no intervention by you. It's observational. But it has a longitudinal nature because you are going to measure something and keep following them up. So, in a way, it's like a cohort study, except that you don't have a clear exposure and no exposure, but you have multiple sets of variables which you're going to decide which of them would be the predictor. That's why I said, if you remember when I talked about research question, it could be intervention, exposure, or predictors. Predictors need not be necessarily exposure dichotomized, but you have many parameters. So you measure all of them. You have not yet formed an opinion as to इनमें से क्या होगा इसका. So you follow up your patients. So at the end of the day, you have some who are surviving and some who are not surviving. Then you go back and put all these variables and say इनकी between the two groups क्या अंतर है और उनमें से जो significant अंतर difference आता है कि ये तीन चीजें predict करती हैं. Then we can go one step further and say ठीक है predict तो कर दिया but I want to give some kind of a score. Then you through a multivariate analysis you can assign a value to it. That means you're saying if you calculate the relative risk of death, let's say variable something has 1.2, the other one has 2, the other one is 1.9. So which means that जो 1.2 है 1 के करीब है, 1.9 and 2.2 are around 2 times. So इस variable को आप 1 का weight दें, बाकी 2 का 2 का weight दें, और फिर आप स्कोर बनाइए 3 लेके कि यदि ये होगा तो उसको 1 मिलेगा, यदि B होगा तो उसको 2 मिलेगा, यदि C होगा तो 2 मिलेगा, तो maximum score 5 हो सकता है, 0 हो सकता है. तो उससे आप that's the way scores are developed for, So I hope, yes. So the first question is, what is the question you have? ठीक है, तो आप the same story. It will be longitudinal observational. It will be a group. No, it now doesn't because your question has changed to say कि इसका ये जो value है. No, but if you want to say कि ये कैसे change होता है, then it's not cross-sectional. Doesn't matter. It's still longitudinal. You're going to look at the change from point A to point B. ये longitudinal. This is the example. Cohort नहीं कहते उसको. Longitudinal That's why I use the term longitudinal cohort. Longitudinal is a good term. Cohort is also a type of longitudinal, but every longitudinal study is not a cohort study. You have plenty of time. Longitudinal studies can be 3 days, 20 days, 1 year, 20 years. Cohort is one type of a longitudinal study. That's all you need to remember. So, though I mentioned that, but I also said, you remember the generic form of longitudinal. That means you're starting from one point and keep going ahead, where you're not intervening, just observing. What's up longitudinal here? It depends. Not necessary. It depends on. ठीक है, वो तो एक ही होगा. एक क्रॉस सेक्शनल है. So there are many. That's why I said I'll not finish. There is a mixed design also, which I'm not. There are mixed ways. You could have a mixture of cross sectional. You could have a mixture of longitudinal. All that also is possible. Some of these are not just clear cut. So that is also possible. I'm not getting into that, but that's okay. Third is your cohort, which is I'll stick to the cohort part of it. So in a cohort study, generally you have a population, and then you identify in that population who are exposed and who are not exposed, and also ensure that all of them have not got the outcome. Keep following them up for a certain period, whatever the period of time required for the development of that outcome, and you will have a certain proposal to develop the disease and not the disease. Right? So here, in case control, we got a proportion of individuals had the exposure with and without the outcome. Here, we'll get the proportion of people who have the outcome with and without the exposure. So we're looking at it from the other side, right? So for instance, if you want to ask question, is smoking a risk factor for coronary artery disease? All right. So a population. So it's a population, something like adults with 20 to 30 years. So 2012 में स्टडी शुरू किया. कुछ सिगरेट स्मोकर्स हैं, कुछ नॉन सिगरेट स्मोकर्स. ठीक है. Do a 30-year follow-up. You'll get some among the smokers who develop CHD and some among the non-smokers who develop CHD. Right? And you can then you'll get some figures, proportion both sides, and then you can subject to some analysis and see whether it is significant or not. The same 2x2 table, the same ABCD. Antar ye hai ki now I'm going this way. Last time I came down vertically, right? I started from outcome and came down to exposure. Now I'm going this way. So here I can calculate, since I have the entire population with me, I know how many of them who are exposed have the disease. What is that? What is the number? What will we look like? I want the proportion of all people who are exposed to have the disease. What is this? What is this? This is incidence. Because new case है ना, हुआ तो किसी को था नहीं, सबको था, exposure किसी को बीमारी नहीं थी, कुछ टाइम के बाद आपने कैलकुलेट किया, ना ये बीमार हो गए, तो आपको इंसिडेंस मिल गया. यही आपको नॉन एक्सपोज में मिल सकता है. Those are not exposed also उनमें से किसी को बीमारी होगी, तो वो आपको परसेंटेज इंसिडेंस मिलेगा. तो आपको 2 इंसिडेंस मिलेंगे. Incidence of the disease among exposed, incidence of the disease among the non-exposed, which you could not have got in your case control. When I take the ratio of these 2 incidences, I get a risk ratio. Risk ratio is nothing but the ratio of incidence of disease among the exposed upon the incidence of disease among the non-exposed is your relative risk. जो RR लिखा जाए relative risk, this is what it is. The risk we'll get from here. So it's a ratio of 2 incidences, right? As compared to case control where we talked about odds ratio. So here it's relative risk. Okay.
Sir?
Yeah.
this study, this question of coronary relation between coronary artery disease and smoking being a risk factor. If I had really to do a study like that, I would actually do a case control study rather than 30-year follow-up and all that to see ki kitna coronary artery disease.
That I'll come back to later as to.
No. I'm just saying the same thing if we put it the other way round, because we could also do it in a cross-sectional manner. The same thing.
We can.
At most, the cross-sectional will give us the possible association.
Absolutely, I agree with you. There's no problem. I'll come back to that. There are more than one ways to answer the same question. It depends on time, money, resources available. मेरे को जल्दी से जवाब चाहिए तो case control.
Okay.
Then I come to this. There's something called a retrospective cohort. We already talked about prospective cohorts, but can I go back in time? And why do you call it retrospective? So it's like this. That means I have all those people. I mean, they were all followed up longitudinally from 1975 to 1995. They've been followed like a cohort, right? Today I get interested in this cohort, saying, ठीक है, original study तो कुछ और outcome के लिए था, लेकिन आज evidence है कि जो exposure थी उससे कुछ और भी हो सकता है जो study में उस time plan नहीं था. So today I pick up all these people and measure them for this new outcome today. But I can utilize the prospectively collected data. It's like a case control of sorts, but the only difference is the data except the outcome, all the other data had been collected prospectively. But because I have a new outcome, which I've discovered today is related to that, I call it retrospective because the only thing I'm measuring today, I'm not selecting anybody, remember, by the case of control. मेरे को पता भी नहीं है, मेरे को पता है कि ये cohort एक है, उन सब में measure कर रहा हूँ. तो उसमें से कुछ आएंगे जिनको outcome है या नहीं, exposure तो मेरे को पता ही है. So I'm now looking at another outcome. Though I'm measuring it much later, I did not as a investigator start with the cohort, but I've entered at some later time, measured only the new outcome, but all the data which I'm going to relate to has been prospectively collected. So retrospective cohorts data are very useful because the data has been collected prospectively in a systematic manner, well-defined definitions, etc. Unlike case control, जो किसी को पूछो क्या हुआ था, जिसको बीमारी है उसको याद होता है, मेरे को risk factor के जिसको बीमारी नहीं याद नहीं होता. You ask a cancer patient how much you smoked, he will tell you everything. You ask a person with cirrhosis liver, he will tell you exactly his whole story of how accurately, how much he drank. You ask somebody who drinks and who doesn't have liver disease, okay, हाँ, मैं इतना पी लेता हूँ. Person with disease remembers much more of the experience because it's been drilled into him by this time that this is what happened. So there's what is called a recall bias because of that. But इसमें वो नहीं है, so therefore if you have a population, you can use it. And this is one example. This was a study published in 2013. So these were births born in UK 1958. They have been followed something else. In 1976, they all underwent as part of the cohort, they're looking for psychopathology. And they found that some children had psychopathological findings and did not have. Then somebody came up with saying that there's a relationship with irritable bowel syndrome and your childhood psychopathological status. So this gentleman decided, okay, in 2000, he looked at all the cohort and assessed them for whether they had irritable bowel syndrome or not, and utilized the already measured data, which has been done the entire cohort of psychopathology for a period of 24 years, and then drew an association. So this is a retrospective cohort. The irritable bowel syndrome story was picked now. The rest of the data has been prospectively collected. So therefore, you can do such studies, are very valuable wherever they exist. So, well, just to say that case controls are useful when you have rare exposures, cohorts are good. If you have rare disease, then a case control is better because rare disease तो follow करते करते नहीं मिलेंगे, लेकिन rare disease अस्पताल में आ ही जाते हैं ना, रेफर हो जाएंगे अस्पताल में, तो you get a good burden, और उनके फिर पूछो कि exposure क्या है. So rare disease के outcomes के लिए, for rare outcomes it is good to have a case control, but for rare exposures, cohorts are better. जहाँ long latencies are there, of course, case control is a good way to do that. It's cheaper, shorter time, it's less resources. But in a case control, what you can't do is to give a temporal association. You can't get causality. You can get an association, but not causality. Because when you have a temporality, कि पहले exposure, उसके बाद बीमारी, so you know there's a relationship. Today, when I have somebody with disease, I don't know whether your disease is actually कब आया. I know you got disease now, but I don't know how long you've had it and whether those exposure also existed. So I can talk about association, but not about temporal relationship. Well, this is just very quick on randomized control trial. You have a reference population from which you want to do based on inclusion-exclusion criteria. You have a treatment, no treatment, you have an outcome. It's like a cohort study. In a way, it's a cohort study. Because exposure तो है ये दोनों में. फर्क यही है कि cohort में exposure naturally हुआ है. Here, you are in. So, you look at the similarity between the way a cohort is analyzed and the way a randomized control is analyzed is similar. Exposure to outcome. But the only difference is that this assignment to the exposure group was done by you as the investigator. Okay, this is just an example. So there are a few issues you need to understand. There's randomization, which is important. Randomization serves the purpose of, number one, bringing some kind of equality of all characters. So when you do a randomization, it's assumed that all the characteristics other than the exposure will happen equally across the groups. This happens quite often, but sometimes it may not happen, right? So it removes the bias for allocation, and it, I told you, tends to produce some respective comparability to some of the risk factors, but there are still some unknown factors also maybe, which you don't know, may also is assumed mathematically that they are similar. The second question is about allocation concealment, and there are ways or means, because you have to ensure that people don't know about it. So there are many methods to do that. I won't go into the details. Then something called blinding, which means that people must not know who got the exposure, who had what's happening. So blinding is, so the patient is blinded, the investigator who's measuring the baseline is blinded, the person measuring the outcome is blinded. When everybody is blinded, we call it triple blind, right? Otherwise, generally, most studies are double blind. There's also another study design called crossover. This is done for drugs with relatively short half-lives. And the advantage of this is the same patients are used for both. So it's very good. Then there's no question of whatever characteristics you have for here, they're identical. So first you expose people to one group of people to drug A, to drug B, and you look at the outcome, then you stop till the drug gets washed out, then you switch them over. The advantage here is you can do the study in half the number of people. Suppose I want 100 in every group for a randomized control trial, हम 50 में कर सकते हैं, क्योंकि I have the number of observations will still be 100 because I'll have 25, 25, 25, 25 in each group. That means half the number of patients, and the most important subjects are identical. So therefore, there is no question that there's any likelihood of characters not being shared. So it's done for several. You look at the efficacy of, look at drug metabolism and short effects. There are other things that we do, which is called systematic reviews and meta-analysis. Here there is no primary data collection, but you look at the data sets pooled from several published data. You can do it for observational studies, you can do it for randomized control trials. So, कोई study 100 मरीज का है, कोई 50 का है, कोई 150 का है. So when you put all of them together, it's like one big study of 500 people. It has its own pluses and minuses, but it's still a good way to look at how various diagnostic tests, etc., happen. So largely it was used for randomized controlled trials, but today you can do it for any study design. You can do it for all. All right. Things I haven't covered here are things like operational research issues, mixed designs, panel studies. There's several others because, like Aarti said, I mean, my question may have many nuances, so I may have to do a mix. There will be some cross component, there may be longitudinal component, there may be something else. So there are ways by which you can address those complex issues, but majority, as I said, will. So coming back, those 5 questions and what kind of designs. So if you're looking at the burden of problems, the magnitude, just measuring, it's invariably, or either it could be cross-sectional, even cohorts can give you, because cohorts give you incidence. You keep following somebody and say how many develop the disease, new disease. So cohorts can give you burden of new disease. Otherwise, cross-section will give you the prevalence of these diseases. Profile, usually they're cross-sectional. If you're looking at associations without temporality, cross-sectional, you're looking at risk factors for disease, usually they're case control. They're likely outcomes or to an exposure. So there are cohorts or longitudinal, as I said, that with that. And if you want to look at treatment, there's only one way. If you have an intervention, whether it's a surgical intervention, whether it's a medical intervention, yoga, whatever, there's an intervention. Randomized controlled trial, if you have more than one arm. The other example is what I told you, you could have a single arm, pre-post. Okay? And generally, diagnostic and prognostic tests could be cross-sectional, could be longitudinal. Like you said, I want to look at prognostic factors. So I can't do it now. If I have a new test, for example, I have some ELISA or something. I have a gold standard, let's say my culture for typhoid, I have an ELISA. I take a blood culture also, I take the ELISA sample. I get the answer, it's cross-section, like I know what is the sensitivity, specificity of the test. But if I'm looking at several things and say, will it predict mortality? Then there's a longitudinal nature to it. So it's still a diagnostic test, but then this predictability is longitudinal nature. So this is what will possibly happen. I think, I hope that I have been able to kind of make it as simple as possible. There are many issues, but I assume that if you even remember these, I think 80% of all that we do every day easily answered. It's also not only because we should be, I don't think we are all going to be researchers, but also it's very important to know this because when you read biomedical publications, you should know कि वो जो कह रहा है सही कह रहा है कि नहीं. इतना तो ज्ञान होना चाहिए कि वो is the right design, उसने सही किया है कि नहीं किया तो then chuck that evidence in the dustbin and say I'm sorry, I won't look at it. What most of you do is read the abstract, खुश रह के सब कुछ है, but methodology पढ़ के सब बेकार है, should be actually in the dustbin. So don't restrict yourself to the abstract. The title and abstract are only to say that I'm interested, but to know whether the evidence is sufficiently good, you must be able to go through and say, इसका research question ये था, did you use the appropriate design? Did you use the right things there? And then when you look at the way analysis is done, did you do it correctly? Then you say, ठीक है. You don't need to know the maths of the analysis, but you should know did they use those principles? So we know those principles, it was followed, then you have reasonable reason to believe कि जो ये कह रहे हैं, probably the evidence is reasonably okay. Okay, I think I'll stop there.